Hello guys, we meet again in partial fraction techniques. So now our focus will be on question number 9. If you want to decompose this fraction into partial fraction, you need to focus on your denominator. So as we analyze here, the factor that we have is a quadratic, because the highest power of your x is power of 2. And the highest power of your x is 2. But now you need to be very careful, because now the quadratic function are going to repeat it twice, because you have a power of 2 here. So now let us look into our main table there. So if we have a repeated quadratic factor, we are going to go for the last one here, which is you are going to use ax plus b for sure. But now you are going to have another ax plus b, because you have your quadratic function twice. So let's say if I put here power of 3, so you need to continue with another ax plus b. So now let us go back into our question number 9. So in order for us to decompose it into a partial fraction, what we are supposed to get here, we are going to immediately get ax plus b, because we are now dealing with a quadratic function. And here we are going to write it as x squared plus 4 plus another ax plus b. Since the value of a and b is taken, so you are going to use another constant, which is cx plus d divided by x squared plus 4. This is supposed to be d, not 0. So let me write it clearly there. It's supposed to be plus with d. But since you have a power of 2 there, so you are going to put your denominator up until power of 2. So this is the way how you decompose the repeated quadratic factor. Then you are supposed to find the value of a and b plus with c and d here. So you are supposed to find all the value of your constant, which is you need to find what is the value of a, b, c, and d. So I think for this part, let me give you some time to try it. We show you the last part, or immediately I will give you the solution for in this video. Okay, I do believe after you try to do some calculation, you are supposed to get up until this part. So here we can do the comparing coefficient method, which is you have 3 groups now, because this is x cubed, x power of 1 and 7, but here you have 4 groups, x cubed, x power of 2, x, and without any variable. So we cannot do comparison because we have a shortage in a group of left hand side, because we only have 3 groups here, and we have 4 groups here, a, b for a plus c, and 4b plus d. So 1 group, 2 group, 3 groups, 4 groups, but here you only have 1, 2, and 3. So what we are supposed to do now, let us try to complete the group in your left hand side, where you are going to get here 4x cubed plus with 0 x power of 2. Since you don't have any x power of 2 here, we just need to try to make it into existence by adding the value of 0 in front of x power of 2, plus with 16x plus with 7 equals to ax cubed plus bx squared plus with 4a plus cx plus with 4b plus d, another group. So now you have a balanced group for each side, so you can do the comparison. For the x cube here, we have a equals to 4. For the x square group, you can see that the value of b now is equals to 0. For the x power of 1 group, you have here 16, so it will be 4a plus c equals to 16. So a is already known there, which is equals to 4. So 4 times 4 plus c equals to 16. So 16 plus c equals to 16. So c equals to 0 also. And the last part is 4b plus d equals to 7. So since we already know the value of b is 0, so it will be 4 times 0 plus with d, which is 7. So you can say that the value of d is equals to 7. So what we are going to do next is, all the value of a, b, c, and d, we are going to replace it back into our main partial fraction here, where you are supposed to get here the value of a equals to 4. So it will be 4x plus with 0. Here it's supposed to be 0 on this part. So it will be plus 0, so should be nothing there. It will be x squared plus 4. Plus with cx, so since the value of c here is equals to 0, so 0 times x will be 0, and the value of d is positive 7, so you only left with 7 over x squared plus with 4 power of 2. So this is your partial fraction now. Okay, so please make sure you do the correct decomposition, and the rest of it you just need to deal with the same method. The most important thing is the first step, or if you make a mistake on the first step, so you can actually see the consequences that your calculation is meaningless. Alright, so see you in the next video where we have a special case for it, where we can see that we are dealing with the improper fraction on how to solve it. Okay, thank you guys. See you in the last video.